Hello, and welcome to Whispers of Earth, a place where quiet wonder meets the wide expanse of science, where curiosity is allowed to wander without hurry. Tonight, we won't be diving into the mystery of how the universe was born or where it's headed. Instead, we're turning our gaze downward, under our own feet, to ask a question that is both simple and unsettling. What if we weren't the first? Not the first to think deeply, to invent, to explore. What if, long before the age of pyramids, satellites, or late-night science shows, there was another civilization right here on this planet? A society that grew into something intricate and intelligent, only to vanish so completely that the Earth itself forgot them? I'm not talking about legends of lost continents or visitors from beyond the stars, but about something real, native, biological, perhaps intelligent in a way we don't entirely grasp, so old that nearly every trace has been erased. It sounds like the premise of a science fiction novel. And in a way, it is. But it's also a legitimate scientific question. One that's been quietly whispered in geology labs and raised in conference halls among cosmologists for years. Not because anyone expects to uncover glass towers beneath Antarctica or smartphones trapped inside seams of coal. The issue is subtler than that. The real question is this: if there had been an advanced civilization millions of years ago, would we even be able to detect it? Could any sign of their existence survive the endless grinding, folding, and recycling of Earth's crust? Or would every last trace, their buildings, their language, even their skeletons, have been consumed and returned to dust, rendered indistinguishable from natural rock and soil? Before we chase what might lie hidden in the long layers of time, I'd love to know, where in the world are you listening from, and what hour is it where you are? It's funny, isn't it? We're about to ponder civilizations that may have lived tens of millions of years ago, and yet right now, across space and time, you and I are sharing this quiet moment together. Wherever you are, whenever you are, I'm glad you're here. And if you enjoy questions that unfold slowly, questions that burn gently rather than flare up and vanish, I'd be grateful if you tapped like or subscribed. It helps this little signal find others like you, others who wonder in the dark. Of course, no pressure. Just an invitation, like faint tracks in the soil that might, if we're attentive, lead to something unexpected. So, settle in. Maybe lean back. Let your thoughts stretch out and slow down to something closer to the pace of continents drifting. Tonight, we'll peer not into the archives of human history, but deeper, into rock, into silence, into the furnace of time itself. Because before we can ask whether someone else walked this path before us, we need to understand how much time we're actually speaking of, and how relentlessly efficient this planet is at sweeping the slate clean. When most of us talk about ancient history, we usually mean a few thousand years. The pharaohs. The builders of Stonehenge. The first symbols pressed into clay tablets. Even if we extend our reach to the earliest known societies, we're only traveling back 10 or 12,000 years. To us, that feels impossibly remote. We call it the deep past. We fill shelves and museums with speculation, debate, and fragments. But in geological time, that's hardly anything. A blink. It's closer to the present moment than to almost any other chapter of the planet's story. And yet, to us, it's vast enough to feel immeasurable. The truth is, Earth is unimaginably old. Not merely millions of years, but billions. Roughly 4.5 billion years, give or take. For nearly all of that time, no humans walked here. For most of it, there weren't even mammals. For enormous stretches, there wasn't any life on land at all, only tiny, invisible things swimming, multiplying, waiting, evolving in silence. And yet, despite how barren that sounds, this was when Earth's true story was being carved out. Layer by layer, stone by stone. The record of those eons doesn't look like a diary. It's fragmented, partial, often quick to forget. Wood rots. Metal corrodes. Bones dissolve. Time isn't just a passage, it's an active force. It buries, it crushes, it melts and erases. Mountains rise and collapse. Oceans widen and close. Continents drift, smash, and fracture. Every few 100 million years, the very face of the planet transforms into something unrecognizable. And so the question isn't why evidence disappears. The marvel is that anything survives at all for longer than a few million years. So let's play with an idea. Picture Earth 100 million years ago, well into the age of the dinosaurs, but long before their end. Imagine something intelligent evolved then. Upright or not. Land-dwelling or oceanic. Maybe it didn't build in stone or metal. Maybe it didn't need to. Maybe it used forms of technology we wouldn't even recognize. Perhaps it lived for a while, grew complex, even cultivated culture. And then, one way or another, a shift, a catastrophe, or simply the attrition of time, it was gone. And now, we arrive, millions of years later, asking the quiet but heavy question, would we even know? Here's the harsh truth, we're not as permanent as we'd like to believe. Our skyscrapers, highways, satellites, and libraries, none of them are designed to endure the patient grinding of geology. Leave a city untended for a few centuries, and nature reclaims it. Leave it for thousands of years, and you'd struggle to even see where it once stood. Give it a few million, and the land will have shifted, sunk, or risen. What was a mountain may be rubble. What was land may be seafloor. Most of it gone. And this isn't just fantasy. Archaeology already shows us how fragile our traces are. Even evidence from relatively recent prehistory is rare, not because humans weren't doing much, but because Earth is mercilessly good at recycling. Take fossils. We often imagine them as common, but the truth is they're exceptional. The fossil record is incomplete and patchy, not because life wasn't abundant, but because the process that preserves it requires just the right conditions: quick burial, mineral replacement, protection from erosion. And then, even after that, luck. Most living things never become fossils at all. Now stretch that reality across tens of millions of years, and you begin to see how easily the story could slip through our fingers. And it isn't just bones. Tools vanish. Structures collapse. Metals corrode. Plastics crumble. Concrete weakens. Without deliberate preservation, almost everything we make dissolves back into the churn of the earth. So, if a civilization had flourished in the remote past, especially one that didn't carve giant monuments from stone, what hope would we have of knowing? You might be wondering, has anyone in science actually taken this question seriously? The answer is yes. In 2018, two researchers, Gavin Schmidt and Adam Frank, published a paper that didn't claim a vanished civilization existed, but asked how we could possibly detect one if it had. They gave this thought experiment a playful name, the Silurian Hypothesis, borrowing it from a British science fiction show where ancient reptilian beings once ruled Earth. But beneath the wink of the name, their inquiry was sincere. Their focus wasn't on skyscrapers in fossil beds or lost machines buried beneath the Arctic. Instead, they asked, what durable fingerprints would industrial civilization leave in the geological record after millions of years? They looked at subtle things, chemical traces, isotope ratios, odd concentrations of rare elements, or molecules that don't occur naturally. In other words, they thought like detectives searching a crime scene where the body, the weapon, and the witness are long gone, but where the wallpaper might still hold clues. And that leads to a sobering idea: the absence of evidence might not be evidence of absence. Maybe we simply underestimate how well the planet cleans the surface every few 100 million years. Civilizations don't vanish neatly. They burn, dig, farm, build, waste. They leave footprints. But those footprints fade. If an earlier civilization went through its own industrial age, would its legacy show up as strange chemical signatures in rocks? A disruption in climate records? Oddities in sediment cores? Maybe. Or maybe the signs would be faint, swallowed by time, mistaken for natural events. Even today, our impact is being etched into stone. Scientists sometimes call this the Anthropocene, a proposed new epoch marked by human influence. Plastics in the oceans. Nitrogen from fertilizers embedded in soils. Concrete scattered across the globe. Radioactive isotopes from nuclear tests. All of these are forming a line in the strata that future geologists, if there are any, might notice. But here's the bigger question: how long will those traces last? And how recognizable will they be if tens of millions of years pass before anyone looks? Thinking this way isn't idle speculation. It forces science to test its own blind spots. The rock record isn't perfect, it's full of holes. Some eras are richly preserved, others wiped nearly clean. Sediment can be eroded faster than it's laid down. Whole chapters of the planet's diary are torn out by earthquakes, swallowed by oceans, or folded into mountains. And then there's the sea itself. Oceans cover over 70% of Earth's surface, hiding anything that once lived along vanished coasts. The ocean floor is young by geological standards, rarely more than 200 million years old, and constantly recycled through the slow but relentless conveyor belt of plate tectonics. Anything built on a shelf or island could have long since been drawn into the mantle, turned into molten rock, and erased forever. So we circle back to our present moment, building and recording, convinced of our uniqueness, wondering if we're alone in the cosmos but rarely asking if we've even been alone here. Maybe the past was silent. Or maybe it was loud, and we've simply forgotten how to listen. Let's not rush. Before we go further, we should ask a simple question: what exactly counts as a civilization? In everyday speech, we often think of civilization as cities and governments, writing and monuments, skylines and infrastructure. But that's a very modern view, a narrow lens. Even among humans, civilizations have taken forms wildly unlike one another. Some built roads and temples, others left little behind but fields and stories. Both still count. Anthropologists and archaeologists use a more careful checklist. Civilizations are marked by traits such as urban centers, organized labor, centralized leadership or governance, surplus agriculture, symbolic or written communication, long-distance trade, religious or cultural systems, and social hierarchy. Not every civilization checks every box. Some do it in unexpected ways. What matters isn't fitting a strict definition, it's whether groups of beings organize themselves at a scale beyond simple survival. Civilization is better thought of as a spectrum. Somewhere between small groups of tool users and planet-shaping societies, there's a wide stretch of possibilities. It might mean a culture that built structures meant to outlast a single lifetime. A species that stored knowledge and passed it forward. A society that reshaped its environment deliberately, for reasons beyond instinct. That doesn't sound like much. But in evolutionary terms, it's colossal. And if it happened more than once, if it happened long before us, it deserves to be taken seriously. Take an example from our own history, Çatalhöyük in modern-day Turkey. About 9,000 years old, it wasn't a city in the way we imagine. It had no streets, no grand plazas, no writing, no monuments. Instead, homes were clustered together, walls pressed against walls, and people entered their dwellings from the roofs. Yet archaeologists consider it one of the earliest urban settlements. Not because of what it looked like, but because of the pattern, coordination, shared rituals, food storage, burial customs. It was society at scale, built over generations. Civilization, even without grandeur. Step further back, and the traces grow fainter. The earliest hints of symbolic thought, pigments, carvings, shaped tools, don't look like our technology, but they still speak of memory, planning, even belief. Minds reaching beyond the immediate. So if we imagine a civilization from not 10,000 years ago, but 10 million, or even 100 million, what would we expect? That depends entirely on what they were like. If they built with wood or plant fiber, the evidence would be gone. If they buried their dead without durable markers, bones might remain, but their meaning would be lost. If they never invented writing, or used a form we wouldn't recognize as writing, their stories would vanish completely. And if they lived in environments hostile to fossilization, rainforests, swamps, coasts, the chances of their memory surviving drop almost to nothing. Even intelligence itself might not look like us. A civilization might not be industrial at all. It might have communicated in ways unfamiliar, chemical, visual, behavioral. Its architecture might have been ecological, ephemeral, collective. Would we even recognize it? Think of termites. To us, a mound is just dirt. But in terms of engineering, it's a marvel: natural ventilation, humidity regulation, fungus farming, collective coordination. A termite colony behaves like a single organism, an emergent intelligence. Scale it up 1,000-fold, bury it for a few million years, and even that impressive structure would vanish into the soil record. That's the challenge. If we're searching for the traces of civilizations that may have come and gone, we can't just look for pyramids and stone circles. We have to think like geologists, archaeologists, and biologists at once. We have to be ready to spot not just ruins, but patterns, chemical oddities, sediment disruptions, isotope ratios that whisper of processes beyond the natural baseline. And we also have to ask, how long does a civilization need to last before it leaves any signal at all? Surprisingly, not very long. Humans have reshaped the entire planet in just a few centuries of industrial activity. In terms of the sedimentary record, that's less than a breath. But the chemical echoes, greenhouse gases, pollutants, isotopes, are measurable. If we were gone tomorrow, would those signals persist? For tens of thousands of years, probably. For millions, maybe. But it depends. And that means if another intelligence ever walked this earth before us, the problem might not be that they left no traces. The problem might be that we haven't yet learned to recognize the ones that remain. If we want to truly ask whether something could survive across deep time, we need to understand what Earth does to its own surface. Because the planet doesn't just sit there. It breathes. It shifts. It consumes. And almost everything left on its skin eventually disappears. In our everyday lives, we see landscapes as permanent. Mountains appear eternal. Rivers seem fixed in their beds. Cities feel like they've always been where they are. But geologists see something else. They see motion in the stillness. Over long enough stretches of time, even the hardest rock flows, bends, or shatters. Peaks crumble. Valleys fill. Continents drift. From this perspective, permanence is an illusion. Start small. Weathering. Rain, frost, wind, heat, these eat away at exposed surfaces grain by grain. Cliffs crumble, roots pry through pavement, metals oxidize, wood decays. Within decades, a building can fall into ruin. Within centuries, even ruins fade into barely recognizable debris. And unless remains are preserved under special conditions, frozen, buried, sealed, they're as good as gone on geological scales. Then there's sedimentation. Soil, ash, sand, dust, all of it collects, layering year by year. That layering can sometimes preserve, but it also distorts. Pressure compacts. Minerals seep in. A wooden beam becomes stone, or vanishes entirely. A buried city might end up as a faint impression in a chunk of limestone, if it lasts at all. And that's just the surface. Beneath it lies tectonics. The outer shell of Earth isn't one solid piece, its plates drifting on molten currents. They collide, fracture, and consume one another. When they do, they trigger quakes, raise mountains, open oceans. And sometimes, they drag whole stretches of seafloor into the mantle, melting them down. Whatever sat there, sediment, fossils, artifacts, becomes not buried, but obliterated. The average age of the seafloor is about 200 million years. That might sound old until you remember Earth is over 4.5 billion years old. Which means the ocean floor has been erased and rewritten dozens of times. If any ancient society lived along the coast, on an island, or anywhere near the sea, their legacy may already be deep inside the planet, recycled into magma. Even continents don't keep records forever. They're sanded down by erosion, scrubbed clean by glaciers, blanketed by lava, remade by rivers and forests. Impact craters the size of cities can be softened or erased with enough time. The Grand Canyon is often celebrated as a book of Earth's history, layers stacked neatly, but even their whole chapters are missing, eras lost, ripped out by erosion or never recorded to begin with. Geologists call these absences unconformities. They're reminders that what survives is the exception, not the rule. Now consider fossils. They're rare, not common. To fossilize requires the perfect storm of events: rapid burial, mineral replacement, stability. Most creatures are never fossilized. They rot, are eaten, dissolve. Even when fossils form, they're usually fragmentary, distorted, or later destroyed. What we have in our museums are the lucky few, survivors against astronomical odds. So if even bones, literal pieces of life, barely make it through time, what hope do we have for the survival of tools, structures, or language? Even in recent human history, archaeologists often reconstruct entire societies from scraps: a flint knife, a pottery shard, a post hole. That's with remains just thousands of years old. Imagine trying to do the same with remains tens of millions of years older, hidden in layers most scientists never dig into. It makes the challenge of proving an ancient civilization not just difficult, but monumental. The burden of proof is enormous. Because it's not simply that we haven't found ruins, it's that the odds of anything surviving that long are vanishingly small. And even if something did survive, it would need to be in just the right place, not subducted, not eroded, not buried too deep, not transformed by heat and pressure. Think about impact craters. When asteroids slam into Earth, they leave enormous scars. Some are hundreds of kilometers wide. You'd think they'd be obvious forever. And yet many are nearly invisible, erased by erosion, or detectable only through subtle shifts in gravity or chemistry. If a crater that large can vanish into the geological background, what chance does a city or a monument have? The truth is, even if we stumbled across something strange in ancient stone, a pattern, an object, a layer, it would be hard to interpret. Most paleontologists and geologists aren't looking for signs of intelligence. They're studying ecosystems, climate events, extinctions. Unless an artifact is unmistakably artificial, it might be dismissed as natural variation. Nature, after all, can create strikingly complex shapes: crystals, veins, erosion patterns, spherical concretions. A perfect sphere might be a crafted bead, or just a geological oddity. Without context, who could say? This is why Schmidt and Frank's Silurian hypothesis focused less on structures and more on chemistry. Not, what did they build, but, what changes would they have left in the Earth itself? Because civilizations don't just leave objects, they leave impacts. Energy use, farming, mining, industry, all of these alter the chemistry of air, soil, and ocean. And the uncomfortable thought is that even if there were markers left behind, we might already have seen them. A chemical spike in the rock record. A sudden shift in carbon isotopes. An anomaly written off as volcanic or tectonic in origin. The evidence may not be absent, it may simply be hiding in plain sight, misinterpreted because we never thought to ask the right question. That's what makes this line of thought useful, even if no hidden civilization ever existed. It forces us to ask, what are our blind spots? How do we tell the difference between a natural catastrophe and something else? And what would something else even look like if we saw it? Because Earth is good at erasing. But it doesn't erase everything. Some traces persist. And if intelligence once bloomed here before us, whatever it left behind wouldn't look like pyramids or phones. It would look like chemistry. When we think of fossils, we often picture a perfect dinosaur skeleton displayed in a museum, bones laid out neatly, stones standing in for life. But that image is deceptive. Most fossils are partial, shattered, compressed. Fossilization is an exception, not the rule, and even then it gives us an incomplete story. It's like trying to reconstruct an entire movie from a handful of still frames, scraps of film, and a few subtitles that survived. For every species we know through fossils, there may have been dozens or hundreds that left no trace at all. Some never fossilized. Some did, but the fossils were later destroyed. Some are still buried in places we'll never look. The record we study is a lucky accident, a selective snapshot of life's vast history. That's important when we think about lost civilizations. Because if fossilization is already unlikely for bones, imagine the odds for tools, structures, or cultural artifacts. Even stone tools, which are durable compared to most human creations, can be nearly impossible to identify out of context. A chipped rock might be a tool, or just a rock that happened to break in a similar way. Without patterns or surrounding evidence, meaning gets lost. And most materials are far less resilient than stone. Metals corrode, fabrics rot, plastics crumble unless sealed away. Even concrete, which seems eternal to us, eventually cracks, crumbles, and dissolves. This means that even with our own ancestors, the record is incomplete. Consider Homo erectus. They lived for nearly 2 million years, far longer than we've existed, and spread across continents. We have their bones, their tools, hints of fire use. But what they dreamed, how they organized, what they believed, we have almost nothing. Not because they left no traces, but because the traces didn't survive. When we dig into the fossil record, we're digging into the winners of a strange lottery. The survivors. The remains that happen to fall in just the right place, buried quickly, shielded from destruction, untouched long enough to fossilize. That's why mass extinction events stand out so sharply. They involve rapid die-offs and quick burials, which increase the odds of preservation. In other words, fossils are more common in times of disaster than in times of civilization. So, if we were searching for evidence of a past intelligent species, our best chance would be if they lived near one of these rare fossil-friendly zones and were caught up in a preservation-friendly catastrophe. That's a narrow window. And it assumes they even left bodies behind to fossilize. What if they didn't? What if a species reached a point where it disposed of its dead in ways that avoided preservation, cremation, burial in the sea, sky burials, decomposition rituals? Then the odds shrink further. And what if they advanced beyond leaving bodies at all? What if intelligence shifted into synthetic forms, or became less biological, more distributed? Then the fossil record wouldn't just be quiet, it would be irrelevant. Even now, much of the matter we handle every day, plastics, alloys, processed chemicals, wouldn't be easily recognized as natural if found millions of years later. Imagine a geologist from the far future finding a thin layer of titanium dust or plastic microfragments in ancient sediment. Would they see civilization, or just dismiss it as a strange anomaly? And here's the bigger problem: interpretation. The fossil record is already shaped by bias, not just in what gets preserved, but in how we read it. We expect to see natural processes. We're trained to look for volcanoes, floods, asteroid impacts. A civilization that vanished millions of years ago doesn't fit easily into the scientific framework. Unless the evidence were overwhelming, it might be set aside as an unexplained blip. Not because of carelessness, but because science demands the simplest explanation that fits. That's why the fossil record doesn't give us the full story. It gives us what the planet allowed to survive, what we've happened to find, and what we've chosen to interpret. But intelligence, especially intelligence that didn't look like us, could easily slip through those filters. Still, fossils aren't our only tool. The Earth keeps other records. Records written not in bones, but in chemistry. In sediments, in gases trapped in ice, in the subtle signatures of processes that reshape air, water, and soil. That's where the question grows sharper. Because if intelligence leaves any durable trace at all, it may not be in artifacts or skeletons, but in planetary chemistry. In 2018, Schmidt and Frank put it plainly: if an industrial civilization had lived millions of years ago, we wouldn't find their buildings or bones, we'd have to look for what they did to the planet. They called this framework the Silurian Hypothesis. The name comes from science fiction, but the idea is firmly rooted in geology. The question is simple: if civilization like ours had burned fuel, mined resources, synthesized chemicals, would traces of those actions remain in the rock record? We already know that our own civilization is leaving just such marks. We're altering the atmosphere, reshaping oceans, scattering plastics, pesticides, and synthetic molecules that never existed before. These changes are already being captured in sediments. Our fingerprints are global and long-lived. So the real puzzle is, what lasts? What could still be visible tens of millions of years from now? Schmidt and Frank broke it down into categories. Geochemical anomalies, shifts in stable isotopes of carbon, oxygen, nitrogen. Burning fossil fuels, for example, changes the ratio of carbon isotopes, and those shifts get locked into sediments and ice cores. If something similar happened long ago, it could be a signal, even if the civilization itself is gone. Another clue would be synthetic materials. Plastics and polymers, chemicals that don't occur naturally. Some degrade quickly, but others could persist for extraordinary spans, especially if buried in oxygen-free environments. Microplastics, for instance, are already showing up everywhere, from the deepest oceans to polar snow. If an ancient layer held similar non-natural compounds, we'd have to ask how they got there. Energy use might leave behind its own residues: ash, pollutants, altered carbon cycles. Large-scale burning produces distinct chemical signatures. Industrial mining and processing could scatter rare metals in unusual concentrations. Even shifts in biodiversity, rapid extinctions not linked to asteroids or volcanoes, might hint at technological causes. The trouble is, natural processes can mimic these patterns. About 56 million years ago, during the Paleocene-Eocene thermal maximum, global temperatures spiked, oceans acidified, and the carbon cycle was disrupted. The fingerprints left behind look remarkably like industrial emissions, but as far as we know, no civilization caused it. So the hard part isn't finding anomalies. The hard part is knowing whether an anomaly is natural, or something else. The Silurian hypothesis doesn't claim we've found proof of a vanished civilization. It simply asks, would we even know if we had? Imagine, for a moment, that humanity vanished tomorrow. No warning, no collapse, no great apocalypse, just gone. What would happen to our world in the days, years, and centuries after? It's a grim thought experiment, but also a useful one. It gives us a way to measure what kind of trace we are leaving behind, and how long that trace might endure. In the first few days, not much would change. Lights would still burn. Cars would sit where they'd been parked. Planes would remain lined up on their runways. But very quickly, without us, the systems we've built to sustain civilization would fail. Power plants would shut down. Water systems would lose pressure. Within weeks, blackouts would spread. After a few months, the cracks would start to show. Buildings would begin to decay, not because of fire or violence, but because nothing is built to run without constant care. Pumps fail, pipes burst, supports weaken. Within years, plants would creep through cracks in the pavement. Trees would take root in empty lots. The line between wild and built would blur. Animals would reclaim territory, first birds and rodents, then deer, coyotes, perhaps even large predators. Subway tunnels would flood once pumps stopped running. Steel would rust. Glass would shatter. Within decades, many structures would collapse under their own weight, especially in wet climates. Concrete, which feels permanent to us, would weaken as rebar corroded, moisture seeped in, and freeze-thaw cycles cracked it apart. Roads would break slowly, overtaken by roots. Bridges would eventually give way without maintenance. Even space wouldn't hold our legacy for long. Satellites would fail as batteries wore out and solar panels degraded. Most would re-enter the atmosphere and burn within a few centuries. Only the farthest, slowest orbits might hold silent metal relics for longer. After 1,000 years, the transformation would be nearly complete. Steel towers would be gone, corroded into heaps. Plastics left in sunlight would crumble into fragments. Underground cables and pipes would have long since degraded. From the air, you might still see the faint outlines of roads and cities, especially in deserts where erosion is slower, but they'd be scars, not structures. Push further, 10,000 years. Forests would reclaim temperate zones. Deserts would shift, burying what remains. Coastlines would be redrawn by erosion and rising seas. Most signs of our presence would be faint, scattered, and ambiguous. Perhaps a few monuments of stone would endure, Mount Rushmore, the pyramids, maybe some deeply carved inscriptions, but even these would weather and fade. After 100,000 years, almost every surface trace would be gone. What remained would be underground, altered soils, filled quarries, ancient mines. Landfills might endure in some form, sealed by layers of sediment. But whatever meaning they carried would be lost unless some chemical clue revealed a pattern. And after 1,000,000 years? Almost nothing. Maybe a few artifacts hidden in caves, deserts, or polar ice. Maybe a few stubborn synthetic molecules lingering in sediments. Maybe a layer in ocean beds that shows spikes of carbon, nitrogen, plastic residues, or rare metals. Not buildings, but echoes. Not monuments, but chemistry. The earth wouldn't erase us out of malice. It would simply continue its work, erosion, tectonics, decay. Time would roll forward, indifferent. And the idea that we were ever here would grow harder to prove. That's not just philosophy. It's at the heart of the question we're chasing. Because if even a global civilization like ours could be wiped away so thoroughly, how can we expect to detect the traces of any earlier one? And yet, some of our most enduring signals may not be the things we built at all, but the things we changed. The chemistry of the air and soil. The isotopes from nuclear reactions. The sudden reshuffling of life itself, extinctions, monocultures, shifts in biomass. These aren't structures, they're transformations. And transformations can last longer than monuments. So imagine you're a geologist millions of years from now, drilling into ancient sediments. You notice a thin, strange layer, high levels of carbon, a sudden drop in biodiversity, traces of synthetic compounds, perhaps even isotopes that shouldn't be there. Would you know what it meant? Would you think civilization, or just an odd anomaly? This is why the thought experiment matters. By imagining our own disappearance, we sharpen our sense of what evidence actually endures. What rises to the level of a geological signal? What would vanish completely? And when we ask whether there might have been a civilization before us, it reframes the search. We shouldn't expect monuments or fossils. We should expect residues. Subtle, chemical, planetary. Because civilizations don't just build, they alter. And those alterations, if we're lucky, are what might outlast the silence of time. Geologists don't measure time the way we do. We count years, centuries, millennia. They speak in layers. In sediments. In isotopes and cores. Deep time doesn't tick like a clock, it accumulates, recording events not as dates, but as changes written in stone. Most of what we know about Earth's past doesn't come from fossils, but from these layers. Ocean sediments. Lake beds. Glacial ice. Rock formations exposed in cliffs and quarries. Each thin stratum is a page in an incomplete archive. Dust falling into a lake. Shells settling on a sea floor. Ash blanketing the land after an eruption. All of it layered, compressed, and stored. It's not a diary, but it has a vocabulary. Carbon levels. Oxygen isotopes. Sulfur traces. Magnetic alignments. Pollen grains. Microscopic shells. These subtle signals tell us about climate, atmosphere, ecosystems. They reveal mass extinctions, asteroid impacts, supervolcanoes. Sometimes they even hint at stranger things. The most detailed records come from places where change is slow and preservation is steady: deep-sea sediments, undisturbed lake beds, polar ice cores. Scientists drill down, extracting cylinders of layered history, and examine them centimeter by centimeter. A shift in particle size, a change in color, an odd chemical ratio, each is a clue. Individually, most anomalies look ordinary. A spike in carbon here, a trace of rare metal there. But together, especially if they appear globally in a narrow window of time, they tell a story. Something sudden happened. Something disruptive. That's why the proposed Anthropocene will stand out. If future geologists drill into our era, they'll find a thin band filled with signals: elevated carbon dioxide, falling biodiversity, synthetic molecules, radioactive fallout. They won't see the whole picture, but they'll see the disturbance. They'll know something broke the rhythm. And if an earlier civilization left a similar mark, even without fossils or ruins, we might expect to see something like it, a strange shift layered into the rock. But here's the difficulty: nature itself produces anomalies. Volcanoes spew carbon. Asteroids scatter iridium. Microbes bloom and alter chemistry. Methane bursts spike greenhouse gases. The planet has its own dictionary of disasters. Without context, it's easy to misread the source. That's why context is everything. A single chemical spike proves little. But if that spike coincides with mass extinctions, if it spreads across the globe, if it includes compounds that don't occur naturally, then suspicion grows. Still, even suspicion has limits. The deeper into time we look, the harder it gets. Rocks fold. Layers vanish. Signals smear and scramble. By the time you're hundreds of millions of years back, clean data is rare. What survives is messy, partial, and easily misinterpreted. And yet, some signals are stubborn. Radioactive isotopes with long half-lives can linger. Shifts in Earth's magnetic field leave patterns frozen in rock, acting like a planetary calendar. Certain minerals only form under very specific conditions, tiny punctuation marks in deep times language. If a civilization altered the planet strongly enough, and in the right ways, maybe those changes would still be legible. But would we recognize them? Even now, scientists occasionally find anomalies that don't quite fit known events. A peculiar isotopic shift. An unexplained chemical spike. Most are eventually attributed to natural causes. Some remain unsolved, catalogued quietly as unusual, and left in the background. Not ignored, but waiting for the right question. And that's the irony. If a pre-human civilization had altered the Earth, its legacy might not be hidden in ruins. It might already be sitting in data we've collected, mislabeled as natural. The signs might be there, but without the right frame of mind, we'd never know what we were seeing. Science is cautious for good reason. Extraordinary claims require extraordinary evidence. To argue that a civilization, millions of years old, left its fingerprints in geology would demand more than anomalies. It would demand patterns so strong, so unambiguous, that intelligence became the most reasonable explanation. That's a high bar. Perhaps impossibly high. Still, that caution leaves open an uncomfortable space. Because anomalies do exist. Deep times language does contain strange words. And until they're fully explained, the possibility lingers, maybe, just maybe, not everything we've catalogued as natural truly is. The Earth's record tells us what changed, when it changed, sometimes even how it changed. But it rarely tells us why. And in that silence sits the haunting question of whether someone else may once have lived, thrived, and vanished, long before us. When we think about civilizations rising and falling, we tend to imagine timelines like ours. A few thousand years of growth, followed by collapse or transformation. But what if the pattern is different on geological scales? What if civilizations appear briefly, flare like sparks, and vanish almost without trace? Human industrial society is only a few centuries old. That's nothing compared to the lifespan of species, let alone the age of the Earth. If we disappeared tomorrow, our period of industrial activity would register as the thinnest of bands in the geological record, maybe just a millimeter in some sediment core. Enough to notice, perhaps. Enough to mark a disruption. But also easy to overlook. That raises a sobering thought: what if earlier civilizations had equally brief windows of prominence? What if they rose, altered their world for a few centuries or millennia, and then disappeared? Their signal would be faint. Narrow. Hard to distinguish from the noise of natural cycles. This isn't just speculation. The history of life shows it clearly. Most species don't last long. On average, a mammal species survives for about 1 million years before evolving into something new or vanishing altogether. Civilizations, if tied to species, may be briefer still. Intelligence might emerge, spread, and then collapse quickly, leaving only faint chemical or ecological shifts behind. So, when we ask, where are the ruins, we may be asking the wrong question. Perhaps there never were lasting monuments. Perhaps there were only short-lived bursts of industry, fires of intelligence that flared and faded before geology could catch them in detail. Look at us. We've already transformed the climate in less than 3 centuries of fossil fuel use. We've moved more earth and rock than many natural processes. We've driven extinctions, reshaped coastlines, seeded the atmosphere with greenhouse gases. Our impact is large, but the timescale is tiny. If intelligence elsewhere behaved similarly, its mark might be shallow, narrow, ambiguous. That's why anomalies in the record, sudden shifts in carbon, abrupt warming events, unexplained extinctions, draw attention. They may be natural. Almost certainly they are. But they also may be the closest thing we could expect to find if civilization happened before. Not ruins, but ripples. One famous example is the Paleocene-Eocene thermal maximum, about 56 million years ago. During this time, global temperatures spiked dramatically. Oceans acidified. Carbon levels soared. Ecosystems shifted. The event lasted around 200,000 years, and its causes are still debated. Most scientists attribute it to natural carbon release, perhaps volcanic, perhaps methane hydrates. But the chemical pattern has an eerie similarity to what humans are doing now. Does that mean there was a civilization back then? Almost certainly not. The simpler explanation is natural. But the point isn't proof, it's possibility. If we looked at that layer without knowing our own history, would we even consider civilization as a hypothesis? Would we even ask? That's what Schmidt and Frank were urging with the Silurian hypothesis, not a claim of hidden history, but a reminder that our methods of detection are limited. That even if intelligence came before, we might miss it unless we know what to look for. And here's another unsettling angle: if civilizations are brief, if they rise and vanish quickly, maybe that's the norm. Maybe intelligence always burns too hot, consumes too much, collapses under its own weight. Maybe our story isn't unique, it's archetypal. If that's true, then deep time isn't empty. It's littered with ghosts. Civilizations that flared for a geological instant, changed their world just enough to leave a faint chemical trace, and then dissolved back into silence. Each one erased, forgotten, hidden in the shifting layers. It's a humbling idea. Because it means our own permanence is not guaranteed. Our skyscrapers, satellites, and libraries feel enduring to us, but on the scale of Earth's history, they're fragile. Dust waiting to happen. And yet, even if intelligence is fragile, it's also transformative. Each flare reshapes the planet in some way. The question is whether any of those flares, past or present, will ever be truly visible to the distant future, or whether they'll all blend into the geological noise, indistinguishable from natural upheaval. Maybe we're not the first. Maybe we're just the first to wonder. If earlier civilizations did exist, one question lingers: why haven't we found even a hint of them? No tools, no carvings, no fragments of language. Nothing to suggest culture or memory. The simplest answer is also the harshest, because there may be nothing left to find. Earth is relentless at erasing. What we think of as permanent is often temporary. Even mountains, which seem eternal to us, are ground down and recycled given enough time. If that's true for stone, what chance do fragile artifacts have? But there's another angle. Maybe we haven't been looking in the right way. Archaeology focuses on the past few tens of thousands of years, because that's where humans are. Paleontology digs further back, but its focus is on natural history, ecosystems, species, extinctions. Neither field is designed to hunt for ancient civilizations millions of years gone. If evidence did exist, it might not even be recognized for what it is. Think about microplastics. Right now, they're everywhere: oceans, rivers, soils, even the air. If we disappeared, many would degrade, but some would become trapped in sediments, fossilized as tiny inclusions. Millions of years from now, those flecks might look like odd impurities in the rock. Without context, would a geologist think plastics, or just shrug them off as curious but natural? Or take metals. We mine and distribute them in unusual concentrations. Aluminum, for example, is common in Earth's crust but rarely in pure form. Industrial processes refine and scatter it widely. In the distant future, if traces of concentrated aluminum were found in odd places, would that be seen as a signature of intelligence, or dismissed as a natural quirk? Even isotopes carry stories. Nuclear testing has already seeded the atmosphere with artificial isotopes, some with half-lives long enough to persist for millions of years. If future scientists found them, would they interpret them as proof of civilization, or invent a natural explanation? The truth is, science is conservative in its interpretations. It prefers explanations rooted in known processes. That's reasonable. It prevents us from leaping to wild conclusions. But it also means that even if civilization left subtle fingerprints long ago, we might already have them in our hands and simply filed them under geological oddity. And maybe that's part of the point. Evidence doesn't speak on its own, it needs a question to give it meaning. Until recently, no one thought to ask whether deep time might hide civilizations. Without that question, the evidence, if it exists, would stay invisible, unrecognized in plain sight. This leads us to a strange thought. Perhaps the hardest part of finding ancient intelligence isn't the scarcity of evidence, but our own expectations. We expect ruins, monuments, skeletons. We expect a mirror of ourselves. If earlier civilizations were different, if they built with unfamiliar materials, if they organized in non-human ways, if they left chemical rather than structural legacies, we might overlook them completely. Imagine, for instance, a species that flourished in the oceans. Suppose they engineered with biochemistry, altering reefs or ecosystems rather than building cities of stone. Suppose they communicated chemically, or through patterns invisible to us. If they vanished, what traces would they leave? Maybe a strange bloom in the fossil record. Maybe a shift in ocean chemistry. Maybe nothing we'd recognize as civilization at all. Or imagine intelligence that didn't seek permanence. A culture that valued ephemerality, building with biodegradable materials, designing to vanish. To them, erasure might have been intentional, even sacred. For us, that would mean silence in the archaeological record, not because they didn't exist, but because they chose not to be remembered. All of this makes the search less about ruins and more about imagination. To find a civilization in deep time, we have to widen our lens. To look not just for objects, but for disruptions. Not just for monuments, but for anomalies. And in that sense, the Silurian hypothesis isn't really about proving someone came before us. It's about training ourselves to see differently. To notice what we might otherwise dismiss. To ask whether absence is really absence, or simply the limits of our perception. Because deep time is vast. The earth has worn and rewritten itself countless times. To assume we already know its full story is hubris. To admit we may have missed something is humility. And humility, in science, often leads to discovery. If we accept that direct evidence of a vanished civilization would be scarce, then what else could we look for? What would truly stand out, even after millions of years? The answer lies in patterns of change. Civilizations don't just build, they reshape. They burn, mine, extract, cultivate. They redistribute matter and energy on a scale far larger than any single species acting alone. And those changes ripple outward into the environment, sometimes in ways that linger long after the civilization is gone. Take agriculture. When humans began farming, we transformed vast ecosystems. Forests became fields. Wetlands were drained. Soils were tilled, fertilized, and eroded. Pollen records from sediments show these transitions clearly, sudden drops in wild plants, spikes in crops like wheat or maize. If another species had engaged in agriculture millions of years ago, might we find similar disruptions? Layers of pollen that don't fit the natural cycle. Soil horizons that suggest deliberate cultivation. Mining leaves scars, too. We've dug enormous holes, moved billions of tons of rock, and concentrated rare elements far from their natural sources. Some of those scars may erode quickly, but others, deep pits, altered strata, tailings full of unusual minerals, could last far longer. Industry produces even stranger signals. Synthetic chemicals. Complex polymers. Compounds that simply don't exist without deliberate creation. Some of these degrade, but others persist. Imagine, millions of years from now, a geologist finding a sediment layer rich in chlorofluorocarbons or microplastics. Without context, it would look bizarre. With context, it would look like civilization. Then there are isotopes. Nuclear reactions leave behind distinctive fingerprints, elements not otherwise found in nature, or found in unusual ratios. Some decay quickly, but others linger, with half-lives long enough to survive across epochs. A thin band of these isotopes in the rock record would be hard to explain without something artificial behind it. And finally, there's extinction. Civilizations can alter biodiversity dramatically. Humans already have, from overhunting to habitat destruction to climate change, we've accelerated extinction rates far beyond natural background levels. If another civilization caused a similar event, the fossil record might show a sudden, uneven collapse of species. Not asteroid scale, but sharp, selective, ecological. This is why some scientists argue that if we vanish tomorrow, the clearest evidence we'd leave isn't buildings or bones, but a global pattern, a sudden chemical spike, a reshuffling of life, a strange thin band in the geological record. Civilization wouldn't appear as monuments, it would appear as disruption. But here's the challenge, Earth's history is full of disruptions. Volcanic supereruptions. Sudden methane releases. Asteroid impacts. Shifts in ocean circulation. Microbial blooms that poison seas. Each of these left its own strange marks, chemical spikes, isotopic shifts, extinctions. They can mimic what civilization might leave. That's what makes the Silurian hypothesis so difficult. It doesn't say there was a past civilization. It doesn't even say there are strong hints. It says that the signals we'd expect are subtle, and easily confused with natural events. That even if intelligence rose before, it may be indistinguishable from the planet's own chaotic rhythms. And yet, the possibility lingers. Because in at least a few places, the signals in Earth's past are strange enough to keep us curious. Events like the Paleocene-Eocene warming, or abrupt extinction bursts without clear causes. Most explanations are natural, yes. But the resemblance to our own moment is hard to ignore. Here's where it gets even more intriguing. If civilizations do flare briefly and vanish, leaving only thin bands of disruption, then perhaps our search shouldn't stop at Earth. Perhaps the same logic applies elsewhere. Mars. Venus. Exoplanets around distant stars. If intelligence blooms and fades quickly, the most durable trace may not be ruins, but chemistry in the atmosphere or anomalies in the rocks. Which means our hunt for extraterrestrial life might already overlap with the search for ancient terrestrial life. We're looking for the same thing, not monuments, but disruptions. A planet out of balance. A system altered unnaturally. A signature of industry written in chemistry. It's a strange symmetry. To ask if Earth once held civilizations before us is, in a way, to rehearse the very questions we'll ask when we look at other worlds. What counts as a signal? What counts as noise? And what if the two are harder to tell apart than we imagined? The past may not answer us clearly. But it prepares us for the future. When people imagine traces of lost civilizations, they often picture ruins waiting to be uncovered, pyramids under jungles, cities buried in deserts, temples hidden beneath waves. But in deep time, ruins don't last. What endures isn't architecture, it's transformation. That's the unsettling conclusion of the Silurian hypothesis. If there were civilizations before us, their clearest remains would not be buildings, but planetary shifts. Not monuments, but chemistry. And if that's true, then maybe we need to rethink what we expect to find, both here and beyond Earth. Consider Mars. Billions of years ago, it had liquid water, rivers, lakes, perhaps even oceans. Its climate was warmer, its atmosphere thicker. If intelligence had ever appeared there, it might have flourished briefly and vanished before the planet grew cold and dry. What traces would remain? Not cities, those would have crumbled in the thin Martian air. But chemical patterns in ancient rocks? Perhaps. A signal hidden in sediments. Or think of Venus. Once, it may have been temperate, with oceans and clouds not unlike Earth's. Today it's a furnace, its surface scorched, its skies thick with carbon dioxide and sulfuric acid. If a civilization had existed there, it would be gone now, erased by runaway greenhouse effect. But the planet's chemistry, the extreme conditions we see today, could itself be a legacy of catastrophic change. Natural? Almost certainly. But the thought lingers, what if worlds we write off as lifeless once held brief sparks of life, industry, culture? This idea reshapes how we search for extraterrestrial intelligence. Traditional SETI listens for signals, radio transmissions, beacons in the dark. But if civilizations flare and fade quickly, signals may be rare. Instead, their most lasting footprints might be atmospheric, unusual gases, unexpected imbalances, isotopic patterns. Not messages, but scars. And that thought circles back to Earth. If we want to understand how civilizations leave scars, we only need to look at ourselves. We're in the middle of leaving one now. Rising carbon. Plastics. Artificial isotopes. Mass extinction. These are the markers that will outlast us. They'll be our calling card in the geological record. The humbling truth is that our permanence is fragile. We tend to see ourselves as the pinnacle of history, but in deep time, we may be only another flare, another brief experiment in intelligence. The difference is that we have the ability to reflect, to ask whether others came before, and to recognize our own vulnerability. That reflection matters. Because even if no one came before us, the question forces us to think differently about our place in time. To recognize that civilizations may not be the grand, enduring structures we imagine, but fragile, fleeting phenomena, bright in their moment, but easily erased. And if that's the case, then perhaps the most important part of this question isn't whether we're the first. It's whether we'll be the last. Because if civilizations tend to vanish quickly, then our challenge is to break that pattern. To outlast the odds. To become something more durable, less fragile, more attuned to the planet we're part of. And maybe that's the real gift of the Silurian hypothesis. It doesn't just ask whether others came before. It asks what kind of future we're writing into the stone beneath our feet. Will we be a thin, strange layer that future geologists puzzle over? Or will we find a way to endure, to build something that lasts not just centuries, but millennia? Something that bends deep time to carry our story forward? The Earth will answer eventually. But until then, the question remains open. When we zoom out far enough, the question of ancient civilizations stops being about archaeology and becomes about patterns. What does intelligence do to a planet? What changes are universal, and which are unique to us? Right now, we can only study one data point, ourselves. Humanity. But even that single point tells us something important. Intelligence reshapes energy flows. It reorganizes ecosystems. It concentrates materials. It alters chemistry. These may be the fundamental fingerprints of any civilization, no matter how alien or unfamiliar. That's why scientists are so interested in anomalies in the geological and fossil record. Because anomalies are disruptions. They suggest a system behaving in ways that don't quite fit the baseline. Most disruptions are natural. But if intelligence existed in deep time, its traces might look similar, buried within that same catalog of anomalies. It's worth pausing to ask, why does this question fascinate us so much? Why do we care whether there were civilizations before ours? Partly, it's curiosity, the same impulse that drives us to explore ruins, read myths, or peer into telescopes. But there's something deeper. If intelligence has arisen more than once on this planet, it would mean that consciousness, culture, and technology aren't fragile accidents. They're possibilities written into the fabric of life. They may be rare, but not unique. And if they've arisen before, they could arise again, elsewhere, elsewhen. That shifts the story from, we are alone, to, we are part of a larger pattern. It reframes intelligence not as a one-time fluke, but as a recurring phenomenon, one that the universe may attempt again and again. On the other hand, if we are the first, if Earth has only just produced a technological civilization after billions of years, that tells us something sobering, too. It suggests that intelligence is extraordinarily rare, that we may be the outliers in a universe mostly silent. If that's the case, our responsibility grows even heavier. We may carry a torch no one else ever has. Either way, the question humbles us. It stretches our sense of time, challenges our assumptions, and asks us to see ourselves not as the center of history, but as a brief experiment within it. And perhaps that's the greatest gift of deep time, perspective. Civilizations come and go, species rise and fall, planets themselves change faces. The Earth does not revolve around our existence. It never has. It never will. Yet here we are. Thinking. Asking. Wondering if someone else once looked up at the same sky with the same questions. The evidence, if it exists, may remain hidden. The odds may be against us ever knowing for sure. But in a way, the lack of certainty is what keeps the question alive. Mystery has a way of sharpening curiosity, of pulling us forward into deeper inquiry. And maybe, just maybe, that's part of what civilizations are for, not just to build or to conquer, but to wonder. To step outside of themselves long enough to imagine the invisible. Because when we ask, what if we weren't the first, we're also asking, what if we're not the last? The Earth will keep its secrets. But the act of asking, of stretching our minds across millions of years, changes us. It shifts our horizon. It deepens our humility. And perhaps that is the true legacy of the Silurian hypothesis, not answers, but perspective. So where does this leave us? Have we found proof of lost civilizations buried in deep time? No. The rocks we've studied so far don't show pyramids beneath their layers, nor machines hidden in fossil beds. The anomalies we've seen, carbon spikes, extinction events, chemical oddities, are still best explained by natural processes. But proof isn't really the point. The point is the question. Asking whether we might not be the first forces us to see the Earth differently. To notice how fragile evidence is. To recognize how easily entire histories can vanish, swallowed by erosion, subduction, and time. To realize that what we call forever may last only a blink in the geological record. That perspective changes how we see ourselves. It makes our accomplishments look small, yes, but also precious. It reminds us that if we want to be remembered, truly remembered, we cannot rely on stone or steel. We have to think on scales as vast as the planet itself. It also shapes how we look outward. When we scan the skies for life, when we analyze the atmospheres of distant exoplanets, we aren't just looking for beacons of communication. We're looking for scars. For disruptions. For the kind of chemical fingerprints that any civilization, anywhere, might leave behind. And in that sense, the search for others and the search for our own forgotten past are really the same search. Both ask, what does intelligence do to a world, and how can we recognize the traces it leaves? Maybe the Earth has hosted more than one civilization. Maybe it hasn't. Maybe we are the first sparks of awareness in this corner of the galaxy. Or maybe we're just one in a chain of brief, bright flares, each erased in turn, leaving only faint traces in stone. We may never know for certain. The past may stay silent. But the act of asking opens a door. It teaches us to look more carefully, to think more broadly, to carry humility into our science. And perhaps that humility is exactly what we need if we are to endure. Because if civilizations tend to vanish quickly, if their legacies dissolve into the background noise of geology, then our greatest challenge is not just to wonder about the past, it is to change the future. To become a civilization that lasts long enough to write its story into time itself, one that cannot be mistaken for an anomaly. So tonight, as we close this exploration, the question lingers, what if we weren't the first? Maybe we weren't. Maybe we were. Either way, the answer matters less than the perspective it gives us. Because to stand here, alive in this brief moment, asking such questions at all, that is its own kind of wonder. And with that, thank you for joining me in this long, quiet walk through deep time. Wherever you are, whenever you are, I hope you carry with you the sense that the world beneath your feet is older, stranger, and more mysterious than it seems. And that in the silence of its stones, there may still be secrets waiting to be heard.